So good morning to my dear students of 9th class. Today we are going to continue from where we have left, that is properties of states of matter. In a previous lecture we have discussed about the properties of solid state of matter. Today we are going to discuss the properties of liquid state of matter. We are going to discuss the properties of liquid state of matter. As we have discussed, in a solid, particles are compactly arranged. They do not have intermolecular space. They are rigid in structure and they have different shape. But we are going to start in a liquid as liquids. They do not have definite shape. That liquids do not have definite shape, but they do have definite volume. That is, liquids do not have definite shape, but they do possess definite volume. Then, in liquid states, particles have intermolecular space. In a liquid state, particles have intermolecular space. That is, in a liquid state of matter, the liquid substances or the particles have intermolecular space. In liquid state, the elements or matter do not have definite volume. They have definite volume, and in a liquid state or liquid substances do not have definite shape. Are the three basic properties of liquid state. But while moving from liquid to gaseous state, what we can describe? In a gaseous state, particles do possess a large or a greater intermolecular space. They have very high values of compressibility. Because of these high values of compressibility, or because of this property of compressibility, the gas can be filled in a liquefied petroleum gas or in a compressed natural gas, which we can commonly call as LPG or CNG. But it is in our textual way. Just imagine now, or we will discuss it in applicative way. Currently, we all are facing the threat of COVID-19. Now you will ask me, sir, how can we compare the threat of COVID-19 with the properties of a state of matter or arrangement of particles of state of matter? That is, before COVID-19, in a Mumbai or in a Bombay, we can see CST terminals where people are crowded together. That crowded peoples can be compared with the particles of solid state of matter where they do not have intermolecular space. Then, as the night will progress, as the crowd will decrease, there will be a little distance between two people. There will be a greater distance between the two people, which can be compared with particles of liquid state of matter where they have intermolecular space. But since we are facing COVID-19 crisis, we can say, we are asked to maintain a social distance, means it replaces the particles of gaseous state of matter. In a gaseous state, particles of matter are always spread away from each other. Similarly, we are asked to maintain a social distance from each other to avoid the threat of COVID-19. In this way, we can describe the states of matter or the properties of states of matter in an applicative way. But after that, we will discuss the change in state of matter. Change in state of matter. Just imagine I have an ice cube. After heating that ice cube, which is solid in state, after heating it will be converted into water, which is liquid in state. I will continue heating water. After some time we can see the water vapors, which are gaseous in state. Here, what we are doing? We are consistently adding energy to the substance. We are continuously adding energy to the substance. Means to change the state of matter. we have to either supply the energy to the substance or we have to withdraw the energy from the substance. You will ask me, sir, how it is possible to change the state of matter? By withdrawing the energy. For example, when water vapors are cooled, they will be converted into liquid water, and when we keep the water in the freezer of a refrigerator, it removes the energy from the particles of water and we can see the solid ice. Hence, we can describe to change the state of matter, we have to either provide the energy to the substance or we have to either withdraw the energy from the substance. But in some cases, we can see the solid substances are directly getting converted into gaseous substances. How it is possible? For example, just imagine your mother may have expensive sarees. To take care of those sarees, what she does? She places some naphthalene balls inside those sarees. After 6 months, what we can observe? That the naphthalene balls have disappeared. Why this happens? This happens because of naphthalene is a sublimatory substance. What is meant by sublimation? That is the process of conversion of solid substances directly into gaseous substances by heating. When we heat a given substance, when we provide the energy in the form of heat to the substance, the process in which solid substances on heating are directly converted into gaseous substances, that process is called as sublimation, and the substances which undergo sublimation are called as sublimatory substances. Naphthalene balls is an example. We can write the examples as naphthalene balls. Second one, camphor, are the two common examples of supplementary substances that we see in our surroundings. After this, we will learn in the next lecture or in the next video about evaporation and the factors affecting evaporation. Till then, goodbye, take care, stay home, stay safe.